Right. Good morning, students. Hari. We discussed last week about microbit, right? We understand the basic components of microbit, right? So there are in the front there are LED bulbs, 25 LED lights, right? And switch A and switch B. So these 0, 1, 2, 3, 1, 2 are the uh, inputs. We can give inputs and get the outputs from that uh, digital and analog input output pins are 0, 1, and 2. And there is a 3-volt pin. We can give the voltage from the pin, and there is ground pin as well, right? This is the front of the microbit, right? Then we discuss about the back side of the microbit, right? There is a antenna to get the radio frequency. Here, there is antenna, right? So there is a processor here, processor, and there is a place to give to connect to the computer. So there is a USB, micro USB port here, 8, and we can give the separate power, that is ninth one. The battery connected to connect 3-volt external power supply. Right, this is the battery connector. Right, then there are uh, two. There are sensors, accelerometer and compass. Right. So the microbit contains these kind of sensors as well. Right. Then 11 is pin edge connector. So those are the things we discuss about the micro bit, right? That is about microbit. So we can connect microbit, this microbit through a micro USB cable. That's why there is a micro USB port in the microbit. හරි අපිට microbit එක මේ වගේ cable එකකින් computer එකට connect කරන්න පුළුවන්. Right? When you connect microbit to the computer, you can see separate storage is, we can see separate storage like this, right? So that storage is for microbit, right? When you go to makecode.microbit.org site, there are set of projects you can program from that site. ඒ site එක ගියාම projects තියෙනවා ඒක program කරලා අපිට මෙන්න මේ microbit එක connect කරලා computer එකට මේ microbit එකට save කරන්න පුළුවන් ඒ program, right? Then by after removing the cable we can separately use that microbit without connecting to the computer, right? But you have to give the separate power supply. Separate power supply එකක් දෙන්න ඕනේ. microbit එක වැඩ කරන්න. Right. So we discussed about how to go to that site, makecode.org, microbit.org or makecode.com, right? And there are two ways to program. One is we can drag the blocks, or we can have JavaScript or program the microbit, right? These kind of things we discuss. So later we will do some practical as well, some more pro practicals from the microbit, right? These things we discussed. These kind of things are input menus to get the input to the microbit. So when button A pressed, we can give some instructions to do. On shake means on shake means when we shake the microbit. Microbit එක අපි සෙලෙව්වහම මොකක් හරි වෙන්න නැත්නම් lights පත් වෙනවා වගේ අපිට program කරන්න පුළුවන්. On shake කියන්නේ ඒකයි. On shake when we shake the microbit. Microbit එකේ සෙලෙව්වම මොකද වෙන්න ඕන කියලා අපිට මේකේ program කරන්න පුළුවන්. So we can display some LED lights, right? And on pin Z press P0 is pressed, right? Pin 0 pressed, we can do whatever we want. Button A pressed, right? Like that. Those kind of inputs we can give from the microbit. Acceleration block is to display accelerometer data, right? That means when we walk with the microbit, we can count the steps like that. ඒ කියන්නේ අපිට microbit එක අපි තියාගෙන ඇවිද්දොත් එහෙම අපිට ඒක steps count කරන්න පුළුවන්. This is to display accelerometer data. Light level to display light sensor data. Compass heading display compass direction data. Right? So there is a sensor in microbit. As I said earlier, there's a compass, right? So from the microbit, we can identify the direction where we are heading. අපි යන්නේ කොහොමද කියලා අපි බලා ගන්න පුළුවන් මේ compass data එක, right? Compass data එක. And temperature sensor is also there. We can get the environment temperature from the microbit, right? There is also temperature sensor. So from this block, it will display the temperature data from the temperature sensor. Right. Today's lesson, we are going to discuss about Arduino board. Right? Arduino board is also a microcontroller. So like microbit, we can program my Arduino board as well. So this is something little bit advanced than the microbit. Microbit එකට වඩා මේක ටිකක් advanced board එක. Right? මේකට අපි කියනවා Arduino board එක කියලා. Right? So let's understand the main components of this Arduino board. So remember, Arduino is microprocessor developed by Atmel company. Atmel. Arduino board එක හදලා තියෙන්නේ Atmel කියන company එකේ. Developed by the Atmel company. So it is also consist of several components like microbit, right? So let's discuss those things, right? Here there are digital pins. Digital pins means, right? So we want to give inputs to the board, right? And we want also to get the output from the board. Therefore, there are set of digital pins uh, in the microbit, right? Sorry, in the Arduino board. And there is a mini USB port. We can connect computer through this mini USB port, right? So this is the main part of the Arduino board. This is actually the microcontroller. So we call this as IC of the. So this is an integrated circuit, right? So if you can remember, we discussed about two types of computers. That is single board computer and single chip computer. So this is a single chip computer. That is this IC contains. So it can get inputs, it can give outputs, can process and store data. So this is a single chip computer, right? This is the main part of the this Arduino board, right? Then there are set of pins to get analog data. So there are analog pins to get the analog data, and there are power pins to get the power to the board, right? And we can give the power through a direct power through a power pack, right? So there is a DC power socket, and the power regulator is as well there to regulate or control the power supply, right? Those are the main parts of the uh, Arduino board, right? So there is a mini USB cable to connect USB, connect Arduino board to the computer. So can be used to connect to computer. Second one is electric controller that, as I said, it's a power regulator, controls the voltage given to the Arduino board. This is controlling the voltage. When we give the voltage to the Arduino board, it will control through this electric or power regulator. Right? Then DC power supply is there, power pins also there. These pins can be used to provide electricity from the board to an external circuit. That means, so from the board, when make a this is used to get the power from the board to other devices. මේ devices මේ Arduino board එකට අපිට තව devices සම්බන්ධ කරන්න පුළුවන්. So ඒ සම්බන්ධ කරන device වලට power supply එක අවශ්‍ය නම් මෙන්න මේ power pins වලින් අපිට ඒවට electricity දෙන්න පුළුවන්. Right? So those are the power pins. Then there are analog pins as well, as I discussed, used to send analog inputs, right? So like what are the analog inputs? So through these pins, we can give analog data. Can you give some example for analog data? Analog data? What are the analog data? So we can give analog data through the sensors. So, so we can give as a moisture level of the soil, පස්සේ තියෙන ශක්තිය නැත්නම් ආර්ද්‍රතාවය අපිට පුළුවන් sensor එකකින් input කරන්න මෙන්න මේ analog pins හරහා, right? And what else? Moisture level and speed, right? Those kind of analog data we can input through the sensors. Through the sensors. So analog pins වලින් අපිට sensor එකක් කරහා මේකට inputs දෙන්න පුළුවන්. එතකොට ඒ data මේකට feed කරන්න පුළුවන් අපි මේ board එකට. So that is a use of this analog pins. As I said, this is the main part of this Arduino board. This is a microcontroller chip in the Arduino Uno board. It is produced by the Arduino company. That is a main chip of the Arduino board. And there are digital pins can be used to get digital inputs and to provide digital outputs. There are digital pins, right? So these are digital pins. We can give digital inputs and we can give a digital output as well. We can make it a digitally දෙන්න පුළුවන් නම් inputs අපිට මේ pins සහ දෙන්න පුළුවන්. සහ අපිට output එකක් දෙන්නත් පුළුවන් මේ pins වලින් digital output එක. Right? Those are the main parts of the Arduino boards. So this is the there are several types of Arduino boards. We call this as an Arduino Uno board, right? This is the Uno, Arduino Uno board. I'll show you the Arduino Uno board, right? So this is the board, right? As you see in the right. So this is the Arduino Uno board that is in the book. So you can see the components clearly here. So these are the main components of the Arduino Uno board. Right? This is the Arduino Uno board. So all the components are in the front. එතකොට මේක මයික්‍රෝබිට් එකේ වගේ මේකේ බැක් එකේ මොනවද අපිට බැක් එකේ තියෙන මේ සර්කිට් එක පාස් කරපු තැන විතරයි. ඔක්කොම තියෙන්නේ මේකේ ෆ්‍රන්ට් එකේ. ඒතර මේ පොතේ තියෙන එකම මේ තමයි මේ තියෙන්නේ Arduino Uno board එක. මේක Arduino Uno board එක කියලා කියනවා. එතකොට මේක so we can give power supply, we can give uh, digital inputs, we can give digital outputs, right? We can give analog inputs, right? So those kind of things we can give from this Arduino Uno board. This is the process is same there like a microcontroller. This is a microcontroller. So we can use this board to do different kind of tasks, right? So we this is programmable. මේක අපිට අර micro bit එක වගේ program කරන්න පුළුවන් අපිට අවශ්‍ය දේවල් කරගන්න. program කරලා මේකෙන් අපිට වැඩ ගන්න පුළුවන්. මේ තමයි Arduino Uno board. Right. I'll give you a close Uh, so this is what is in the board, Arduino Uno board. Shall we sketch this down? මේක පොඩි අපි පොඩක් ඇඳගෙන මේ ටික අපි නම්බර් කරගෙන මේකේ කම්පෝනන්ට්ස් ටික ලියා ගන්න එක හොඳයි. So ඊට කලින් right write the topic as Arduino. Arduino is a microprocessor developed by the company. අන්න ඒ ටික ලියා ගන්න. Arduino is a microprocessor. So last week I said that there are several kind of microprocessors. Microbit we discussed last week. So this is kind of another microprocessor. This is Arduino board. Arduino board, there are several kind of Arduino boards. So I showed you the Arduino Uno board, right? This is the Arduino Uno board. Write the topic as Arduino. Arduino is a microprocessor developed by Admet company, right? Then after that, we can draw the Arduino Uno board and we can write the components. So important thing is, as I said, right? It consists of, right? Components shown below. It can receive input, process it, and release the output, right? So therefore, when there is a when we can give inputs and we can process and we can get output. So if there are something like that theory is there, so it is a computer. So basic thing is computer is there is an input and there's process and there's an output. Therefore, this Arduino board is a kind of computer, right? So there is a feature of computer that means there is an input, so it can receive input, it can process it, and it can give the out. Therefore, this is a small kind of computer, right? So take these three lines and write three lines, and then after that we can draw the Arduino board and we can write the components. අපි පොඩ්ඩක් ඉඳගමු. පොතේ තියෙනවා නමුත් ඒක අපිට වැදගත් වෙනවා මේක ඇඳගෙන මේකේ components ටික අපි mark කරගන්න. හරි. ඒක ස්කෙච් කරගෙන අර බෝඩ් එක ඇඳලා මේකේ ස්පෙෂල් කම්පෝනන්ට්ස් ටික විතරක් මාක් කරගත්තා නම් ඇති අපි. මේ So these are the digital inputs outputs. These are the pins for digital input outputs. So you can have the digital inputs දෙන්නත් පුළුවන්. Digital outputs ගන්නත් පුළුවන් මේ pins වලින්. Right? Mini USB to connect to the computer. Right? So this is the main part of the board, Arduino board. This is the microcontroller of the Arduino board. So, and there is a power regulator to control the power. So we can give external power to Arduino board. So these are the power pins. From these power pins, so you can you can know later that to this Arduino board we can connect other devices. To those devices we can get power output from this power pins. මේ Arduino board එකේ pins වලින් right අපිට power outputs ගන්න පුළුවන් මේ power pins වලින් අනිත් devices වල. And there are analog pins as well. We can give the analog signal, analog input through this analog pins. Analog signals දෙන්න පුළුවන්. Right? එතකොට මේ list එක චුට්ටක් අපි note down කරගන්න. මේ මේකේ තියෙන components ටික හරි. Right. මම හිතන එක ඉවර කරගත්තා නැත්නම් පොතේ තියෙන එක එහෙමම copy කරගත්තම කමක් නැහැ මොකද ඒක වැදගත් අපිට ඒ components ටික identify කරලා තියාගන්න එක. This is the Arduino Uno board, right? So this is another kind of Arduino board. This is the Arduino Uno board. Then this is the Arduino Mega board. This is the board that we discuss now. Arduino Uno board, right? This is Arduino Mega board. This is Arduino Nano board, right? This is Arduino micro board. So there are several types of Arduino boards you can use for different kind of projects. එක එක projects වලට එක එක boards අපිට use කරන්න පුළුවන්. ඒවා දැන් extreme යනකොට දැන් මේවා practical ගොඩක් අපිට මේ stage එකේ ගොඩක් practical සිද්ධ වෙන්නේ නැහැ. නමුත් ඉස්සරහට ඔයගොල්ලෝ මොනවා හරි robotics වගේ කරනකොට මේ boards use කරලා එක එක projects කරන්න පුළුවන්. Right? So here, so we are using Arduino Uno board for the activities in this unit. ඒ කියන්නේ අපි මේ unit එකේ අපි පාවිච්චි කරන්නේ Arduino Uno කියන board එකකින් තමයි අපි projects කරන්න යන්නේ. Right? So to go for a practical example, let's describe this one. Right? This is called breadboard. This is called breadboard, right? Breadboard. When you want to connect different kinds of devices to the Arduino board, so it will getting more complex, right? So therefore, there is a system to connect those devices with this breadboard, right? So there are set of holes we can plug Arduino board and other devices to this breadboard and give the connection, and we can program through this connection. So this breadboard is mostly used to connect the devices. එක එක devices connect කරන්න තමයි අපිට මේ breadboard එක අවශ්‍ය වෙන්නේ. Right? Right? This is the breadboard. So there are power pins. There are minus pins තියෙනවා. Plus pins තියෙනවා. ඒතර power supply එක දෙනකොට අපි pins අනුව තමයි අපි board එකට connect කරන්න අවශ්‍ය වෙන්නේ. So අපි ඒක අපි example එකක් බලනකොට ඒක අදහස ඔයගොල්ලන්ට එයි. Breadboard can be used to make circuit without resorting to weld it to connect their circuit components without welding. There is very important point. So normally when we are uh, building circuits, we have to weld them, pass on them, right? But using a breadboard without welding, right? Without welding, we can connect uh, more devices to this project, right? Without welding. එතකොට අපි මේ pins වලට connect කරන්න විතරයි තියෙන්නේ welding කරන්න දෙයක් නැහැ. Right? There are holes marked plus and there are holes marked minus. Plus marks, plus holes are marked as red and minus holes are marked as blue. Right? So that is breadboard. So now we are discussing a kind of peripheral devices that are used to do some projects, and we use light emitting diode, that means LED, right? So normally we know what is LED. We can give the electricity and we can uh, light up these LEDs. When there is a electricity, this will be light, right? So this is a light emitting diode and some kind of sensors are there. So before that, I'll show you some project that is done by Arduino Uno board, right? And how to do that one, we will.
In this video, we built a contactless dustbin using Arduino servo motor, an ultrasonic sensor, and some simple cardboard crafting. Let's dive into the project. Here's what we need for this project. An Arduino Uno, one ultrasonic sensor, ICT-Grade09-24.08.2025, one servo motor, a USB cable, some jumper wires.
අපි මේ අල්ට්‍රාසොනික් සෙන්ස් එක පාවිච්චි කරලා මම මේක සෙන්සර්ස් කරනකොට කියන්න. We use this is a ultrasonic sensor, right? Ultrasonic sensor. So we can get the distance from this sensor, right? We can measure the distance and we can program uh, what should be done when someone reach to this sensor and someone is going away from this sensor, right? So this is ultrasonic sensor to get the distance and we can get the distance input to the Arduino board. This is ultrasonic sensor.
9-volt battery with a battery plate, a piece of cardboard or a small cardboard box, cutter, scale, and glue of tape. Let's start by building the mini dustbin structure. We are going to make a mini vertical box with a leaf on top of that clips open and close. First, take a piece of cardboard and cut off the folding panels, front and back panel, side panel, for base panel, and a top lead attached with a hinge or tape like a flap. Assemble all side panels using glue or strong tape to form a proper box. Attach the base panel at the bottom. Leave the top open and attach the lead only from the back side so it can open and close like a flap. Now let's mount the components. Take the servo motor, stick the servo motor inside the box near the back top gate using glue. Attach the servo motor to the underside of the lead. This will allow the servo to lift and close the lead by rotating it. Now take the ultrasonic sensor HCSR04, attach the ultrasonic sensor so the two eyes peek out, just like robot eyes. Use the glue to fix it in place. Take the Arduino, now let's set up the connections. If you ultrasonic sensor connected VCC to whiteboard on Arduino, it's GND to GND on Arduino. Connect its trig pin to pin 9 on the Arduino and its echo to pin 10. Now let's connect servo motor. Its orange pin signal pin to pin 11 on Arduino, VCC to whiteboard, and this brown pin GND to GND on Arduino. Make sure to double check your connection with the circuit diagram. Now download the code and library files given in the description below. Open the code file in the Arduino IDE. We start by including the servo library, which allows us to control the servo motor easily with simple commands. Now we define trigger underscore pin and info underscore pin for the ultrasonic sensor. Servo underscore pin for the servo motor. Max input distance to decide whether the lead should open. Here we have set it within 20 centimeter. You may vary it according to your requirements. This line creates a servo object that will be used to send commands to the motor. Inside the setup function, strips real communication for debugging. Set trigger pin as output and echo pin as input. Add servo motor to its pin. This is the loop function where all actions run repeatedly. Now we send a 10 microsecond pulse from the trigger pin. Then we measure the time duration it takes for the echo to bounce back. Convert the time duration into distance using the speed of sound. This formula gives us object distance from the sensor. If the object is 20 centimeter, it opens the lead with sound right 90. After 1 second, no object.
ප්‍රෝග්‍රෑම් වැඩි හිතන්න එපා. අපි පස්සේ මේක ඩිස්කස් කරමු. දැන්ට මේක වෙන විදිය විතරක් චුට්ටක් බලාගන්න.
Nearby,
එතකොට මේ program එක අපිට
right function 0.
So we can download this program to our Arduino board and we can program it. This is how it starts.
This helps us keep the live distance recording and reading for debugging and calibration. We wait 1 second before starting the next sensor reading to avoid erratic behavior. Final out. Hand detected within 20 centimeter, then lead opens. No hand, lead closes. Distance continuously shown on serial monitor, and that's it. Now upload your code to the Arduino. Then connect the Arduino Uno to your computer using the USB cable for uploading the code. Select quoted code in the same menu, select the Arduino Uno. Now click on the Arduino button. Power the Arduino using the Arduino Uno to your computer using the USB cable for upload.
This is how we connect Arduino board to the computer. Why we connect Arduino board to the computer? So to download the program, right? To download the program. So when we download the program, so we can remove the cable from the computer, and separately we can use that program without connecting to the computer. But we have to give the power to Arduino board. මොකද Arduino board එක වැඩ කරන්න power ඕනේ. කරන්ට් එක ඕන නිසා අපිට වෙනම power දෙන්න වෙනවා computer එකෙන් ගැලවෙන්න පස්සේ.
In the code, select coded board in the same menu, select the Arduino Uno. Now click on the upload button. Power the Arduino using USB cable if you want to run with standalone. The power it with battery wire is power check. Bring your hand close to the sensor and see the lid opens automatically. After a short, the hand closes back. And that's for today's project. You have just made a mini smart dustbin that helps to stay hygienic and hands-free. All using simple components and cardboard. If you found this tutorial helpful, don't forget to like, share, and subscribe for awesome Arduino projects.
There are a lot of practicals.
Today, I'm going to show you how to build an automated watering system for your plants. Here are the materials that we will use. An Arduino Uno board, a cable with a USB Type-B in one end. This is to power the Arduino board. A 5-volt relay, one channel, a soil sensor, a water pump,
මේ තියෙන්නේ soil sensors. soil එකේ අපි දැන් මේ automatic watering system එකක් අපි හදනකොට පසේ උෂ්ණත්වය අපි දැනගෙන ඉන්නවා. පසේ උෂ්ණත්වය වැඩි වෙනකොට තමයි වතුර වැටෙන්නේ. So how to detect that one? To soil sensors, right? So as I said, to where we need to connect the input of the soil sensor. Can you tell me? To which pin? To analog pins, right? So from the soil sensors, it will give analog signal. Therefore, we should connect this output, the input from the soil sensor.
mobile charger,
Right?
some jumper wires, and plastic tube. The plastic tube, we will use it to connect with the water pump. Let's begin connecting the parts, and we will start with the soil moisture. Take note of the positive and the negative side. All you have to do is connect the positive from the sensor and the positive to the probe. In this case, the red wire is my positive and the brown wire is my negative. Next, I will connect the soil moisture sensor to the Arduino board. If you check the soil sensor, you will see four markings: analog, digital, GND, and VCC. So first, I will connect the VCC of the sensor going to the 3.3 volt of the Arduino board. Then, I will connect the GND of the sensor going to the GND of the Arduino board. And then I will use A0 and connect it to the A0.
I told you that the Arduino board has power output pins, right? So when you connect these kind of the soil sensor, it should have some power in it. So therefore, we should connect that soil sensor to the power output of Arduino, right? Then only it can work. ඒකට වැඩ කරන්න යාට power ඕනේ. So Arduino board එකේ power supply එකෙන් තමයි ඒක වැඩ කරන්නේ.
Of the Arduino. Next is to connect the 5-volt relay to the Arduino. The relay has three markings on one side, VCC, GND, and in. I will now connect the VCC from the relay going to the 5-volt of the Arduino. Then I will connect the GND from the relay going to the other GND of the Arduino. Then for the in coming from the relay, I'm going to connect it to the pin number 4 of the Arduino board. I will now connect the water pump to the relay. Take note of the markings on the other side of the relay. I will connect the positive side or the red wire of the water pump to the COM of the relay. For the power source of the water pump, I'm going to use a mobile charger. Since my water pump is only 5 volts, then a mobile charger will be enough to power it. I'm now going to connect the positive of the mobile charger going to the NO of the relay. Complete the connection, I'm now going to connect the negative wire of the water pump to the negative wire of the power source. That's how your wiring connection should look like. Arrange everything into an enclosure. Let's go to our computer and open the Arduino IDE.
Right, this is the place where
Plug
program
the
the
Arduino board to your computer.
Arduino board.
All you have to do now is copy and paste the code to the Arduino IDE. Click upload, and that's it.
Once you write the code, and you need to upload that code into that program into Arduino board. So there is option to upload. Upload means we are sending that program to Arduino board. After that, we can remove the USB cable from the computer.
If you don't have the Arduino IDE on your computer yet, all you have to do is search for the Arduino and then click download. For the final setup, connect the plastic tube to the water pump and just drop it into the water. Then get the sensor probe and insert it to the soil. So now, when the sensor probe detects that the soil of the plant is a little bit dry, then the water pump will turn on and water the plants. Now let's test the system. Since the moisture in this plant is already high, the water pump is not turning on. So what I will do is remove the probe and let's see if the water will turn on. And there you have it. Thank you for watching and please subscribe to my YouTube channel.
So let's see another one, right, to show you the breadboard, how to use the breadboard.
Okay, so I'm going to start with the module learning now, so part two, and then you've got the LED. This one, we're going to change the brightness of the LED by using different values of resistance. Okay, so basically we're just going to adjust the current going through to an LED by increasing the resistance. So start with 220 ohm resistor, then 1k up to 10k one, or the other way around, whatever. Then to the jumper wires. Okay. Okay, so let's pull out the breadboard stuff and then we'll set.
Today I'm going to show you guys a very simple Arduino project for beginners. We're going to get 3 different LEDs to turn on and turn off in a simple sequence, like you see here. For this, you're going to need an Arduino Uno or similar Arduino board, a breadboard, preferably a positive and negative rail like this one, 4 breadboard jumper wires, a USB cable for the Uno, 3 LEDs of different colors. Here we're using blue, red, and green, and 3 220 ohm resistors. Now we're using 220 ohm resistors because they seem to work the best with the LEDs we have. But you could use different resistors depending on your LEDs and your circuit. I've put a link to an inexpensive Arduino kit that contains all these components in the description below. So let's first set up the hardware. The first step is to establish a common ground. To do this, Use a jumper wire to connect the ground pin on the Arduino to the negative rail on the breadboard. This allows all the LEDs to use the ground pin on the Arduino. Now we'll insert the resistors into the breadboard. Space the resistors out with one leg connected to the negative rail. Now it's time to insert the LEDs. Before inserting the LEDs, it's important to note that the longer of the two leads on most through-hole LEDs is the positive lead. Connecting it the wrong way will cause the circuit to not work. Connect the negative lead of the LED to the horizontal rail on which the resistor is connected and connect the positive lead to an adjacent rail. Repeat this process for all three LEDs. Now it's time to complete the circuit. We're going to use output ports 13, 12, and 11 for the output signal. Connect the positive lead of the LED on the right to pin 13, the LED in the center to 12, and the LED on the left to pin 11. The circuit is now complete. Power on the Arduino board by connecting it to your computer using the USB cable. The LEDs on the board turn on and the board powers up. Before we work on our sketch, make sure to download the Arduino IDE for your specific operating system. I'll leave a link to where you can download the software in the description below. Once you've downloaded and installed the Arduino IDE, go ahead and download the sketch to run this program using the link I've put in the description. Open the downloaded file. The program first creates three variables, LED1, LED2, and LED3. This allows us to change the output pins without having to modify the entire program. The code in the setup part of the program tells the Arduino that pins 13, 12, and 11 will be outputs. The portion of the program is where the actual instructions live. The first three digital write functions turn on one LED at a time with a 200 millisecond delay between each of them turning on. The next three digital write functions turn off the LEDs with a 300 millisecond delay between each LED. And you can change the delay between each LED to change the rhythm of the LEDs turning on and off. Now you're ready to upload the program to the board. Click on the Tools tab of the Arduino window. Make sure the Arduino Uno is selected as your board and make sure you select the COM port your board is connected to. Most of the times there will be one COM port available and that will be the one you need to select. Click on the Upload button on the top left-hand corner of the screen to upload the program to the Uno. A green progress bar on the lower right-hand corner will indicate upload progress. And unless any errors appear in the black message bar at the bottom of the screen, your board should now be running the program and the LEDs should be turning on and off like you can see here. Hope this tutorial was useful. Please hit like for more Arduino tutorials and subscribe to stay tuned. Thanks for watching.
In this video, you will learn how to write a new Arduino program and also get it to blank an external LED. In addition to your Arduino, you will need a breadboard, two jumper wires, an LED, and a resistor. 150 or 220 ohm resistors work well. The breadboard consists of a grid of holes where you can insert wires and other parts like LEDs and resistors to build a circuit.
Right.
You can easily remove.
As you see that the use of breadboard is that we can connect different devices without having uh, right. Without welding, we can connect different devices uh, through the breadboard, right? So this is light empty diode, and there are different kind of sensors, right? So this one is important. Passive infrared sensor, PIR sensor, PIR sensor is used to uh, detect human touch, right? So human when there is a human, it can detect that is a human, right? Like that, it can measure the infrared objects like humans, right? Through the PIR sensor. So this is a PIR sensor. There's a ground pin, out pin, and to get the voltage, right? So this is PIR sensor. And as I show you, this is ultrasonic sensor. So this is to estimate the distance. Estimate the distance. අපි dustbin practically අත ළඟට යනකොට dustbin එක automatically open right? It will give the distance input through this ultrasonic sensor, right? Ultrasonic sensor is used to estimate the distance from it to an object, right? This is done by ultrasound signals to the object and then interpreting the reflected signal. දැන් මේ ultrasound sensor එකේ තියෙන විශේෂත්වය තමයි මේකෙන් ultrasound එකක් release කරනවා. ඒක object එකේ වැදිලා return වෙන්න යන time එක තමයි යා distance එක අනුව තමයි distance එක measure කරන්නේ. That is how it measure the distance. It release the ultrasound and it will touch the object and return back. ඒ කියන්නේ වැදිලා පරාවර්තනය වෙනවා. එතකොට තමයි යා distance එක measure කරන්නේ මෙන්න මේ object එකට මෙච්චර දුරක් තියෙනවා කියලා. The same way this the process of the bat වවුල කොහොමද එයා අඳුරගන්නේ මේ පරාවර්ත එයාත් යවන්නේ අල්ට්‍රාසවුන්ඩ් වේව් එකක් යවන්නේ ඒ වේව් එක එකෝ වෙලා යට එන දුර අනුව තමයි එයා ඒක ඩිටෙක්ට් කරන්නේ මෙන්න මේ මෙතන මොකක් හරි ඉස්සරහ තියෙනවා කියලා එයා ඩිටෙක්ට් කරනවා right so the same way the ultrasound sensor is working there's a ground pin there's an echo pin right trigger කියන්නේ මේ ultrasound එක එයා එළියට යවනවා echo pin එකෙන් තමයි ඒ input එක ගන්න right trigger for the input echo provide the output right echo එකෙන් තමයි output එක යවන්නේ trigger එකෙන් තමයි echo කරලා එන input එක ගන්න echo කරනවා කියන අපි sound එක release කරලා ඒක වැදිලා එන එක input කරගන්නවා මේ trigger එකෙන් so those are the components of this ultrasound sensor PIR sensor to measure the infrared objects like humans. Then ultrasound sensor to estimate the distance, right? So you can have some short note about that, these kind of sensors. Right. Keep a note with this breadboard as well. මේක පොඩ්ඩක් ලියා ගන්න පොතේ තියෙන එක ලියා ගන්න ඇති. So breadboard can be used to make circuit without resorting to welding to connect circuit components. Without welding, we can connect several kind of components using this breadboard, right? Right. So this is kind of we have to do these things practically to clearly identify, clearly understand. Otherwise, this is like Greek, right? මොකද තේරෙන්නේ නැහැ නැත්තම්. මේක බලන් හිටියද එච්චර තේරෙන්නේ නැහැ. හැබැයි මේක practically කරනකොට තමයි මේකේ idea එකක් එන්නේ. ඒ නිසා මම දැන් ගිය සතියේ වණ කිව්වට මම ඒක මේ ජීවේ නැත්නම් මේක තියරි ටික ඉවර කළාම අපි ප්‍රැක්ටිකල්ස් එකක් දෙකක් කරමු. ඒකට ඕගොල්ලන්ට අයිඩියා එකක් එනවා මේක මොකද්ද වෙන්නේ කියලා. right? So we will do some practicals next week with the Arduino board. We try to make the uh, that automatic dustbin, right? If you can purchase those items from the internet. I will send you the link and I will send what kind of things you have to purchase. ලොකු ගණන් වෙන දේවල් නෙමෙයි. මේවා ටිකක් ගත්තා නම් අපිට practically කරලා බලන්න පුළුවන්. And කොහොමද we are going to code them and how to store that code in the Arduino board. Right? Okay. That is end of this lesson and with that practicals we can discuss more about this program section. So in your workbook, there are set of things to do. So we'll do those things as well with that practicals, right? Right. Any questions up to now? So as I said, these microcontrollers, we have to connect to the computer and we program that one and upload that program to the microcontroller and then we can use that program. Again, we microcontrollers වල අපි program කරන්නේ ඒ විදිහට. computer එකට connect කරලා program කරලා ඒක save කරන microcontroller එකේ. එයාට පුළුවන් ඒක separately program එක run කරන්න. Right? That is the most important part. Right. Okay. Done. Then after doing some practicals, we will go to the next lesson, computer net. Right? Any questions up to now, students? Yes or no? මේ බලන් හිටියද ලොකුට තේරෙන්නේ නැති වෙයි. හැබැයි practical එකක් දෙකක් කරනකොට idea එක ඔලුවට එයි. Right? Okay. Shall we meet on next Sunday then? Right? අපි යන ලබන සතියේ හම්බෙමු. මම details ටික දාන්න. Right? Okay, right. We'll meet on next Sunday, right? Goodbye.